Hello everybody and welcome back to another tutorial. About a week ago or 2 weeks ago now I did a video on how to install Raspbian on your Raspberry Pi. I've also showed you how to do it on a VMware workstation. But I've also noticed too that more and more people are getting interested in the Raspberry Pi, more and more people are using it for specialized projects. I can see them in the wild all the time now. And it kind of dawned on me, does anybody actually really know how to secure them or at least give them some kind of security? And probably not, because I know when I first got mine, that was the last thing I thought about was security. I was like, oh, I can't wait to do this cool project. And then, you get hacked at one point. You find out that people are trying to break into your Pi at all the times. So what I ended up doing was writing out this really nice guide you see in front of you, as well as make a video based on this guide on how to secure a Raspberry Pi 4. This will work with a Raspberry Pi 3, 3B Plus, and so on, and 3As and all that other stuff they have. But I wanted to make a video basically surrounding the Raspberry Pi 4. So this all works on the Raspberry Pi 4. This is meant for the Raspberry Pi 4 using Raspbian. If you're using another version of obviously a operating system on there, you may want to verify that all this stuff works. For the most part, a lot of it will work as well if you're using like say Kali Linux or Ubuntu in them. But for the most part, this is actually for Raspbian. Also, I always like to put a disclaimer letting you know that this is no way 100% sure to keep people out. This is just the basic functions that are needed and pretty much to kind of get you going. I do recommend looking more in detail into some of the software we're using today and other features we're using to suit your needs. For example, if you're planning on making this a web server, this tutorial is not going to save you 100% from a web server. You're going to need SSL encryption and certifications, as well as adding also fail to ban firewall attacks to it and so on. So that's realistically not going to be the best solution. But if you just bought a Raspberry Pi and you want to be able to get it secure and have a little bit of fun with it, this video is for you. Also here, I always like to put my prerequisites, everything we're going to go over with. So in the case being, we have to create a new root user, a new our static or IP SSH port. So I always like to put a little information box here for anybody who does want to follow along and download the guide. They can put all their stuff actually in here as well. It is also editable on the PDF. So when you go to use PDF on this, you're able to actually go ahead, click on these spots and type in what you want to type in, for later on. Don't recommend saving it, but in the case being, if you're using this as a lab environment or just trying to get used to it, it's a nice little way of looking at it. So when you see, VM Advisor or you see any kind of IP addresses, you can always reference back to what you have. So enough talking. What we're going to do is we're going to get on into this video here and start off with how to disable and delete your Pi or the Pi username and create a whole new user to take over from what Pi does. Okay, so the first thing we're going to do is we want to create a whole new user. So very simply, it's sudo add user. VM Advisor is the user I'm going to want to create, but you can choose anything else you want. Just don't make it obviously Pi. I'm going to go ahead and press enter. And as you can see here, it's going to go ahead and start creating directories and adding the groups, adding the new user. And then it's going to ask you for a password. Type in a new password. And then once it asks for information about the user, the nice thing is we can just press enter for each one and skip past it. And that's it. So we have a new user ready to go. Now what we're going to want to do is we're going to want to create the user to actually replicate all the groups that Pi is a part of. Okay, so the easiest way of doing that is we need to find out what groups Pi is a part, and then we can just go from there. So you just type in the word groups and then the username, which is Pi. And then you can see here it lists all the different groups that Pi is available for. So what you're going to want to do is you're going to want to copy everything here up into Pi because we don't need Pi anymore. Just like so. Open up another text document and then you just want to paste it in there as you can see I already done earlier. Now the next thing we're going to want to do is we're actually going to want to go ahead and add all these groups to our new user. Now you don't have to add every one if you don't want to. I prefer to just because I don't want any problems later on. So the simplest thing to do is copy and pasting this. But to give you an understanding, all it is sudo user mod. The -AG stands for add to group. And then all the groups that we have up here are all here. And then at the end is the username. Make sure though, as you can see up here, there is no commas between every word, but there is one down here. So if you don't put a comma in, it's going to fail. And that's it. So now I've been added to every group. Now if I want to check it, I can just type in groups VM advisor. And you can see here it lists all the groups I'm a part of, which are the same groups outside of VM advisor for Pi. So perfect. Now to test sudo for us, it's sudo su dash and then the username. Then you just type in sudo who am I, type in your password, and if you get the word root, everything is all good to go. So now what we're going to do is we're actually going to reboot the computer. You can log out, but I've had problems when I log out that sometimes when trying to delete Pi, it doesn't work until I do an actual restart. So because it only takes a few seconds to actually restart the computer, we're going to go ahead and restart. And then just to give you an idea what we're going to do is we're going to come back and we're going to kill off Pi. So all the processes, we're going to take rid of them. And then after that, you have a choice between two ways of deleting Pi. Now, if it's your first time using a Raspberry Pi, delete user, remove home Pi would delete everything, including the home directory. If you've been using your Raspberry Pi for a while and now you just want it to be more secure, but you put a lot of files and everything under the home directory of Pi, you're probably just going to want to delete the user Pi. And then later on add Pi to your group list up here so you can access all the Pi files. But for the most part, you're probably going to want to just use the first one. So we're going to go ahead, reboot the system, and then when we come back, we'll log in as our new user and delete Pi. Okay, so now we're at the login screen. We're going to choose our new user and then log directly in. You want to open up a new terminal, and if you give me a second, I want to make it a little bit larger for everybody. And then all we're going to do is just type in sudo pkill -u for user and then Pi. Then type in our password. And that's it. And what pkill does, it kills off anything that Pi might be booted into already or associated with at the time. Makes it easier for when we want to actually delete Pi from the system, because sometimes if your Pi is still connected, you're going to get errors when we delete the user and they have to go in there and start removing processes or deleting it from processes. It becomes a little bit of a nightmare. So we're going to actually go ahead now and type in sudo del user for delete user, remove home, -pi. Now again, if you've been using a Raspberry Pi and you have stuff stored under your home directory of Pi, do not run this command. Run the del user Pi command. But because we're doing this as a fresh install, I want to delete home and delete everything that Pi stands for. Press enter. And then, as you can see here, it looks for all the backup files and everything else, removes it, removes the user, gets rid of the group, and that's it. So if you do get an error saying that you have a processing error or something like that, chances are you probably have something running like SSH, GIPO, something of that nature, and you have to have that turned off. So what I like to do here is when I go into my Raspberry Pi configuration, inside my Raspberry Pi configuration, I also like to make sure auto login for Pi is turned off and all my interfaces at the time are turned off. Now, because I'm doing this in the virtual, again, we're missing a bunch of different interfaces that we can use, like the camera, GPIO, and so on. But in still a sense being, you want to make sure they're all turned off just in case. Sometimes when I've had SSH turned on or log in as a user as Pi, it still gives me an error when I delete Pi. But that is technically everything we needed to do. So like I said, if we go back here, and if you just want to check out the home directory, no more Pi. So if you want to do, for instance, just check out the user, we can just type in sudo su Pi, user doesn't exist, groups for Pi, no such user for Pi. So at this point, we're looking very good. And what we're going to do next here is we're going to go ahead and show you how to do all your SSH configuration from your Pi to your new user. Okay, so now what we're going to do is we're going to want to create an SSH encryption from one device to the other. Now, in this tutorial, it's going to be from Linux to Linux. If you have a Windows computer, I recommend you watching my video on PuttyGen, and it explains to you how to create an encryption from Windows to from Microsoft to Linux. But the process on the server is exactly the same on how the SSH file will be configured and so on. It's just a different method of how to create an encryption key from one computer on Windows to a Linux device. So the first thing is we're going to want to enable SSH. Now, there's a good chance you probably have it turned on already, but if you don't, it's actually a very simple command. And we're going to type in sudo systemctl start SSH. And then we're going to want to go ahead and look at the status to verify it is running and working. Okay, so now we're going to want to go ahead and edit the config file. Now the config file is going to be pretty much changing port numbers, certain access, and pretty much how to get it to work properly the way we want it to. So we're going to type in sudo nano etc ssh sshd config. Now in here, we're going to want to change a few different things. For the most part, yours is going to look similar to mine. The only thing that's going to be different is I've actually already changed my port number without realizing it. So you're going to want to go down the port here, and normally it's going to be port 22, but you want to make it anything else besides that. So in this video, I'm going to make it 2200. But you also want to make sure you don't make it any kind of port that's already currently in use. Example, don't use 80 or 443, 25, and so on and so forth. There's a list on the internet of all the different dedicated port numbers, so check that out if you're not sure which one it is. But in this instance, 2200 I know is available, so we're going to use it. All right, and that's it for the moment. Eventually we're going to come back here and change a few more things, but we have to get the key over to this server before we do that. Otherwise, we won't be able to copy anything over. So we're going to go ahead and save it. And then for everything to take place here, we're going to want to go ahead and type in restart SSH. And we'll go ahead and restart SSH. So now what we're going to do is we're going to hop on over to our other computer, and we're going to create a key, copy it over to the server, and then finish the encryption. Okay, so now we're on our Linux Mint server, and I'm going to want to go ahead and just test out SSH to begin with. I just want to make sure that I can log into it with no problems. So SSH VM advisor at 192.168.100.10-port 2200. And there we go. So as you can see, I'm logged into our server, our Raspberry Pi. So I'm going to want to close out of that. And now I'm going to want to create the keygen. Now, very simply, just going to copy and paste that here. When we copy and paste it, it's just SSH keygen-t RSA. Do not use sudo in this scenario. If you use sudo, it's going to only be allowed for root to log in. So every time you try to log in, you're still going to be denied because you're not root. You have to log in as root. So make sure it's SSH-keygen and not sudo. Press enter. It's going to give you the location of where they're going to store it, which is fine for me. If you want to put it anywhere else, you're more than welcome to type it in, but I'm okay with the default location. The paraphrase it's asking for is the password to unlock the private key. So when I try to SSH into our server, it's not going to let me do it until I actually type in the password to unlock the private key for me to do it. I like to add this because it's a little extra layer of security, but if you don't want to put a passphrase in, you don't have to. And that's it. So you can see here, everything's been created. We're all good to go. It has created two files, the ID RSA, which is a private key, and then the public key. And the public key is what we're going to want to transfer over. So our next line that we're going to pretty much copy and paste very easily because I don't feel like typing everything in. Okay, and pretty much what this is doing is just telling you to copy the ID from idrsa.pub over to our Raspberry Pi. So press enter. Asking for the password for a Raspberry Pi, and that's it. So now we can go ahead and try to log in using the new phrase that they have there. So SSH-P 2200 VM Advisor, if I can spell. Type in the password if you put a password on your private key, and there you go. Now I don't feel that it's much faster if I do it that way as opposed to this way. But maybe it is because I'm just a slow typer today. But as you can see here, it's the exact same thing, just in different formatting. And there we go. Okay, so now what we're going to do is we're going to want to hop back over to our Raspberry Pi, do a few more tweaks in the SSH config file, and then hop back over here just to verify everything is working. Okay, so back on our Raspberry Pi, we're going to want to do a few things here. We're going to want to first off go back into our SSH config file, and now we're going to pretty much lock it down. Now, to let you know that if you plan on adding any more extra keys and so on, you're going to have to change a few things in here or manually come over and copy and paste the key over, which is not a problem. The keys that get pretty much put into everything are right here. So you can see authorized keys. Here's the key that came directly from my Linux Mint, and as you see at the end, it has that here. So if you want to add any keys, this is the folder, and this is where you want to add the keys to. So when you do this lockdown and you don't want to have to, manually, change the file back or open up password text and so on, this is how you're going to copy the keys over. So, but in this case, we've copied all our keys. We only want the one person. We're good to go. So now let's go in here and start changing things. So first things first, authentication. This is optional, but I do it anyway, just out of practice. Permit root login? No. Even though the Raspberry Pi root is technically disabled, it does have root, and it can be re-enabled if you really want to, and cause massive destruction. So with SSH, I still keep it turned off no matter what. Then we want to go down here to password authentication. See how this is set to yes? When we change this from yes to no, that means if you don't have an actual encryption key, it's not going to prompt you for a password. And without that password prompt, well, we're not going to be able to get into our server through SSH. This is actually very good, but again, this is the scenario where if you're trying to copy multiple keys over, you're going to want to come in here and re-enable this real quickly, just so you can copy the key. Or you put on a flash drive, plug it into your Pi, and then copy it manually. Either way does work. Then we're going to go down here to use PAM, and then we're going to press no. Okay, and pretty much what this does, it just pushes more security against the password authentication, the challenge response authentication, as you can see from the description above it. And that's technically it. You can add users if you want to it, but considering this is a Raspberry Pi, we're only probably going to have one user that logs into it on a regular basis. It's probably safe to sit there and say we don't have to worry about adding multiple users, but you can if you want to. At the bottom of it, you would just have to add in a section called allowed users, and then just type in the username you want to allow. Same thing with denied users. If you want to deny users, you can do the same thing as well. Also, if you want with denied users, you can always put like Pi, if you didn't delete it, root, other different users that are logged in here for like dev and everything else, in case somebody's able to figure out how to use them. But for the most part, it's not required. Go ahead and save the file, restart SSH, and now I'm going to hop back over to Linux and just to make sure everything is all working properly. Okay, so now I'm back over here on my Linux server. And what I'm going to do here is I'm going to just SSH back into it and make sure everything's working. And there we go. Now, as you can see here, I wasn't prompted for a password, and it's mainly because I'm still logged into the computer. Once you log out, the password for the encryption resets itself. And I think it also resets itself like every so many hours, I think 24 hours, or you can change that information if you want. But for the most part here, everything is still working. Now, what I'm going to do is I'm actually going to bring up a putty from Windows and show you that logging into Windows from this, so another computer, onto this server is not going to work, and we're going to be, shown a rejection screen. Okay, so here is my putty, and what we're going to do is I'm just going to go ahead and log into our Raspberry Pi. So now it's going to say log in. We're going to type in the user that we're allowed to log in, and there we go. So pretty much it's telling me that I don't have a public key attached to this, and I do not have authorization to use a password, so I'm unable to log into it. And that's about it. Now, there are other things you can do. Obviously, this is just a basic setup for SSH. I am creating another video at the moment that is more in detail SSH, like adding banners, a few more other protocols that stop people from it. So check out that video once it releases. But as of right now, we are successfully connecting to our Raspberry Pi using encryption. So the next two things we're going to go over are UFW and fail to ban. Now, in short, UFW is the universal firewall for Linux, and fail to ban is technically a software that monitors your protocols and connections. And if you happen to try to log in too many times with too many failures, it does exactly what it is. It fails you. So every time you fail, it logs it. Once it realizes that you're probably, DDoSing or trying to, hack the system, for lack of better words, it goes ahead and bans you for a set amount of time. So what we're going to do first is UFW, because that usually gets installed first, but technically you can install either or as you want. So UFW is pretty simple. If you don't actually have it installed, it is sudo apt install UFW. And then it goes and finds it. Some Raspberry Pis have it pre-installed, or depending which version of Raspbian you have. My version obviously doesn't, but that's how you would install it. All right, so now it's installed, and we're going to want to check the status. So sudo status UFW. Oh, backwards, my bad. All right, so as you can see here, status is inactive. And we want that. We don't want it to start up right away because it's going to start disabling a lot of our connections until we do the configuration. So in my little document here, I pretty much wrote out a very quick few ports you want to kind of enable or get them going with before you start doing anything. Now, this is by no means, shape, and form the most full setup here, but it's the basics. The first line is 2200, our SSH. Or whatever your SSH port is, mine is 2200. Then we have port 80 and 443, both are allowed for internet, obviously. And then as you can see here, incoming denies everything. So anybody who tries to come in with any other port besides those three gets denied. And outgoing, we allow all. Now you can change the deny all outgoing as well, except for those three ports. That is up to you. But for me, I kind of just leave outgoing as all, because if realistically, nothing should be phoning anywhere else unless you know about it on your computer. So you can always add other ones too by doing the same thing with sudo UFW, and then you have three options: limit, allow, and deny. Allow and deny, self-explanatory, so I'm not going to go over that. Limit actually limits the amount of connections available for that. Usually you put them on like FTP servers, SSH, SSH protocols and stuff like that. That only allows a few connections so often to connect to it. So, and actually go ahead and set these things up are very simple. It's just now the copy and paste game. And as long as everything's good, you'll be greeted with rules updated. Now, if you already have it installed, so we'll just do this again, it will let you know that you already have the rule enabled already. So in this case here, we're going to go ahead, change this to allow 80, and we're good. And the same thing again, 443, and we're good. And you can do it anything like that. So it's honestly, I'm going to want to limit, and I actually have Webmin installed, which is another web-based software. If you don't know what that is, check out my video on Webmin, and it explains everything about it. But I need to make sure that's open and available too, because I need to connect to it. So then we have the two other ones, which is the default for deny for incoming and the allow. Now, default is exactly what it is. It's the default information for everything else. So if you haven't specified it, what is the default for that? So if it doesn't see it in the rules here, what is it supposed to do? In this case here, if it doesn't see it in any of these rules, deny. Okay. And then the same thing here with outgoing. Again, you can change it to anything you want, which would be allow or deny. I'm saying it's allow because, again, it's outgoing. It's not coming in. And that's about it. So again, if you want to check again, we'll go ahead back up to the status. And you can see it's still inactive. So we have to go ahead and enable it. So sudo UFW enable. Can never get it right the first time. Oh, so I can't spell. And now, as you can see, it's active and enabled. And let's check the status. So now you can see status is active. And all the ports that we've said is A-OK is right here. And the same thing with version 6. If you're not using version 6, it's fine. Still keep them obviously there because that's the default they have for it. And that's it. There's nothing else you really have to worry about with configuring. Now, there's other things to configure with it. But unfortunately, we're not going to go over that in too much detail in this video outside of just this. Because we're just trying to get you the basic information of getting you ready to go. It's the same thing with the fail to ban, which we're going to go over now. There's a lot you can do with fail to ban, but in our case, we're just going to go over the very simple basics to get you up and running. So now we have fail to ban here. And fail to ban is very simple. All right, there is a lot we can do with this, a stupid amount we can do. But for the most part, we're just worrying about SSH because that's the only thing we have on our server here that we need to worry about people logging into. There's nothing else that they can log into our server, so there's no reason to worry about configuring other scenarios. But fail to ban does a lot. So same thing, sudo apt install fail to ban, Y for the install, and within 10 seconds later, you're ready to go. Maybe 15. Okay. So the next thing we have to worry about here is the jails. Now that's how fail to ban works. It runs off of a jail.local file. It gets their information from the jails.config file. So what I'm going to do here is I'm actually just going to log into this folder here and show you what it's all about. Just so you can see how much information is actually in here. So as you can see, 890 lines. It's a lot of lines. So as it says here, don't modify this file. And that's fine. We don't want to modify this. We're actually going to create a whole new file. But I do like to create a copy of this file. Just because in case something goes wrong or there's a problem. Or sometimes I just take it out to look at everything. But I don't want it to actually have any problems. But pretty much everything in here goes and configures fail to ban and how and what actions to do and what to take, to go ahead and finish it. So you see you have SSH here, the porting and everything else we want to worry about here. If you're using SE Linux, SSH, exactly what's going on, your HTTP, Apache servers, what ports are they using this. So there's a lot we can do. But we're not going to have to worry about all this configuring because we only got to worry about one or two things. So first things first, I'm going to want to copy this over. Not move, but copy. All right, so what this did right here was that it copied the jails.config to jails.config.org. So if any problems ever happen with this file here, it gets deleted or any kind of problems I have, or I edited things not paying attention, I can just revert it back with this, which is perfect. So the next thing we're going to do is we want to now create the jails.local file. So simply sudo nano etc failed to ban jails.local, not .config.local. Press enter, and you can see it's a whole new file, which is fine. This is exactly what I want because I only wanted to actually look for one thing. I don't need to go through all those files there to figure out everything. I just need you to figure out what I want you to do. So we have two options here. We have our basic SSH and our permaban. This is a preference. It's up to you how you want to do this. So we'll go ahead and paste it. So as you can see here, we have two things. First thing is port number. Make sure your port matches whatever port you chose for your SSH. I chose 2200. And then you have the max retry and ban time. Max retry is up to you. You can do 6, 8, 10, 12, 150, 2, doesn't matter. I choose 3. If you get your password wrong in 3 shots, it's time for the ban hammer. Now, the ban works in seconds. So everything is calculated in seconds. So if you want to ban them for a minute, 60 seconds. 10 minutes, 600. So on and so forth. Okay? Now, 86,400 is the actual time for 1 day. So if you get it wrong, you're ban hammed for 1 day. The other time people use is 3,600, which is 1 hour. You can't log in for a whole hour. So it's up to you on the number of how long you want to make it. This is not really anything else. But in some cases, some people like to do the permaban. And the permaban is anything with a negative number. So when you do your ban time here, you do -1. It doesn't know how to read negatives because there's no such thing as negative. So what it does, it automatically blocks you and adds you to the blacklist, and you'll never be able to log back in again. Now, you're using this as a Raspberry Pi, and if you are the only one that's supposed to be logging into this, and you know your password because you did everything else, you got your encryptions on there correctly, everything's good to go, this isn't a bad thing to have because, again, I don't want somebody keeps trying to attack me every hour, every day, or every so on. So having a negative number for the permaban works fine in my case. And as I like to always add, permaban. Now all you gotta do is just save the file, and that is it. And now some people go ahead and restart their computers if you want, or your Raspberry, and make sure everything works out fine. In this case, you really don't actually have to, but if you want to, you're more than welcome. And now for our final little quick lesson on what to do is automating your updates. Now, for the most part, people who do all their updates and everything, we know how to do updates. It's sudo apt-get update, and then you can always add sudo apt-get upgrade -y. Now, I know I spelled that wrong up here, and that's okay, but this is mainly how you do all your updates. You run this command real quickly, it finds everything, and you're good to go. But we don't always have access to our Pi, especially if they're out in the wild and everything. And sometimes we actually don't really pay attention all the time when an update comes through, and now we have to do it. Me personally, I got about 10 of them out in the wild. So trying to remember all 10 of them all the time to make sure they're always updated isn't always #1 on my priority list at times due to whatever kind of workload I have. So I went ahead and found a script, edited it a little bit, and now I'm able to just have them update every Sunday using crontabs or crontab. All right, so it's very simple. What we're going to end up doing here is we're going to make two directories. One is your script file and the other one is a log file. Both of them are going to be under the home directory. Then we're going to create an update.sh script that we're going to put again in our scripts folder. Then we're going to copy and paste this whole script over, make the script executable, and then we're going to use crontab to actually run the script every Sunday at midnight. Sounds simple enough. Forgot to add that right there. All right, so let's get going here. So first thing is we got to make some directories. Go ahead, make the two directories, and there we go. So just to verify they're there, boom and boom, here they are. Properties, see, I am the owner, I can do anything. We're all good to go. All right, so the next thing we're going to want to do is we're going to want to create the script. So again, we're going to want to nano into the scripts folder and create a file called update.sh. Press enter. Okay, so now we're in here, and very simple, you can just go ahead and copy and paste what I have in my guide down below into here. And as you can see, there's a few things that are tacked out. RPI update and reboot. That's up to you and how you want to do it. Me personally, RPI update I only run if I need to. So let's say like once every so often. And what RPI update actually does, it updates the kernel to make sure the kernel is okay and anything. But I usually but kernels take so long to come out that usually when I find out that a kernel update is happening, I usually just run it by myself. But I did add it into here in case I want to. Then we have the first line, which is clean the apt archive cache. So when you're doing actually upgrades, it's nice to have that empty, especially if you have like a small amount of data left on your Raspberry Pi, like your SD card's kind of small. But for the most part, it's not really needed too much. But I like to add that in there just in case. Then we have the apt-get update, and then you have the full upgrade. And the difference between regular upgrade and full upgrade is exactly that. A update only just shows you whatever comes out. An upgrade only shows you whatever comes out at the time. A full upgrade verifies that everything on your Raspberry Pi is up to date. Everything, not just the programs that you have or the ones that just are showing updates now. It checks everything. Auto remove, very simple. It removes any dependencies or programs that are not in use, mainly dependencies. So if you have a dependency in your system, in your library, and it's not being used by anything anymore, it will go ahead and remove it for you. It does not remove anything that's like any actual programs or files or anything like that, so don't worry. Auto clean does the exact same thing the first thing does, where it just goes and cleans out repositories, caches, and anything that's left over from behind. And again, reboot is self-explanatory. Now, as you can see here, we don't use sudo for anything, is because cron tabs will actually do it without sudo. You don't need it to run these files. It's going to run it automatically under root. So we're going to go ahead and just save it. Next thing we got to do is we're going to make it executable. So very simple. You have two ways of doing this, but we can do it right here through terminal. Sudo change modifications for the file, plus X means to make it executable, and what file are we executing? Good to go. So now if I go over here to our scripts file, so if we double click it, come on, it pops up now. It's an execute file. So we can either execute it or execute in terminal, up to our choice. But at least now we know it is executable. And then the final thing is we have to add it to the crontab startup. So I'm just going to copy this. Choose our text editor. We've been using Nano, so let's use Nano. Now pretty much it breaks everything down here for you, but I'll just go over it real quickly. What this thing here says is right up here is the month, the minute, the hour, the day of the month, the day of month, the month, and the day of the week. So the way this script is set up is to run at midnight, which is 4 zeros, every month or every day, or any day technically is what pretty much when you see this, it means any day. This one means any month. And then this 0 is the day. Now the day works from 0 through 7 technically, which is really odd because that. So 0 and 7 are Sunday. They're both the same number. 1 is Monday, 2 is Wednesday, so on and so forth. You can also write the abbreviation, so you can write SUN, MON, TUES, WED, THUR, FRI. But for the most part, I like to just put the numbers there. And then at the end here is just the script. What kind of script are we running? We're running an SH bash script. This is a script location. And then we want to copy all the output to the logs file under cron logs, which again, good thing I catch this because I actually did this wrong as well. There we go. And that's it. You can go ahead, save it. And there you go. So now you're actually all ready for your system to be automated. It's going to go ahead and on Sunday, if you ran with that script, Sunday at midnight, it's going to go ahead and update your system to the fullest. And there you have it. How to secure a Raspberry Pi 4 server. Everything we went through in these video segments is pretty much how to get you started on securing your Raspberry Pi. Again, this is no way, shape, and form 100% to stop anything. And there's definitely more things you can do, and there's definitely more tweaks you got to do depending on what you're using your Raspberry Pi for. But for the most part, this will get you going. Disabling your Pi and creating the user, the SSH configuration with encryption, installing UFW with configured ports, installing fail2ban and configured it for SSH only at the moment, and then how to automate your server and keep it updated when it's out in the wild. So again, this guide right here, you can go ahead and get down in the description below. And everything that we went over in these videos goes into more detail a little bit. As well as you can see here, it goes into more detail about crontab, about how to actually set everything up, and a little bit of examples down here of how if you want to set up a very special and customized way. Also at the bottom here, I did link a section for backup your Raspberry Pi. Raspberry Pi is very important to backup. The problem is that there is so many different ways of doing it, and not every way is 100% safe and fail-proof. And because there is so many different ways, it's hard to cover in one video, or actually just in a video. But pretty much the safest way of doing it, if possible, cloning your Raspberry Pi SD card. You know, when you get a chance, take it, plug it in, clone it the way it is, you're good to go. The most ideal situation is that, but again, it's not going to happen. Most people are going to have it. If it's out in the wild, you got to make sure you have like rsync or some kind of NAS connection to it. Like say a flash drive plugged into it where you can copy everything to a flash drive for it at all times. I like to have mine connected to my Dropbox and send it to the cloud. There's so many different ways of doing it, but you do have to run that. I do think I'm going to make a video of that in the future. I'm just trying to figure out where I want to start and kind of which is the best for almost everybody, not just one person and one in particular person. So if you like the video, like, subscribe, let me know in the comments if you have any questions or concerns, you have any problems with anything, and I'll do the best I can to help you out. Also, come on back. I do videos as much as I possibly can all the time, especially now that we're all in quarantine, so it makes it very simple to do videos more often. And yeah, so I hope everybody has a great day, and I'll catch you guys on the next video.